Good morning. This is Rich Ness, Executive Vice President with Open Systems Media, and I'm here for this week's installment of 5 Minutes With. This week I have the pleasure of interviewing an old friend. Well, I don't know how old he is, but somebody who goes back into my history, and that would be Finbarr Moynihan of MediaTek. Good morning, Finbarr.
Good morning, Rich. Good to connect again.
Absolutely. So where are you located these days?
I am based in MediaTek's offices just a little bit north of Boston on the East Coast.
Ah, that's the accent, that Boston twang. I get it. Okay.
With an Irish undercurrent.
Oh, I hadn't detected that. Okay. Very good. Okay, so we only have 5 minutes, so let's dive into this. You're the general manager at MediaTek, and I know that you guys are into Multicore in a very big way. What I've seen of Multicore for a while now is that people seem to be on this track of jamming more cores into the same die. There has to be more innovation than that, aside from sticking more cores in. So explain to me why that there's a lot more innovation than I'm aware of.
Yeah, it's good. It's a good point, and it's a good topic. I mean, I think you're right. I think if you look at some of the, particularly for us, I would say mobile, but you see some of the same trends in our home platforms as well. Over the last couple of years, these SoCs have gone from, single core ARM processors to dual core, quad core, octa-core, and we even now have also introduced some 10-core solutions. And I think there's kind of two things going on here. One, there's always these conflicting requirements between high performance and low power in these systems, right? So, and they're always in conflict, right? You can have high performance or you can have low power, but trying to do both with the same core is nigh on impossible. So I think what's been driving these innovations and these architectural steps has really kind of been trying to balance those competing requirements of, consumers who just want more performance, more capability from their devices, but they also want them to last the whole day or a certain amount of time. And you're right. I think in the early days of this, if you go back 5 or 6 years ago, what was happening really was we were putting down multi-cores from single core to dual core to quad core, really in an attempt to chase performance, right? As the Android ecosystem was taking off, the need for more performance was there. I think that's sort of slowed down recently over the last 2 or 3 years, and really much more focus has gone into kind of optimizing the architecture. It's not really about more cores now. It's about how you use the cores that you decide to put down. So is there an optimal number of cores, or is that based on your application and all that other stuff? Yeah. In our industry, and in kind of we're talking mostly about like smartphones and tablets and mobile kind of computing devices, what we've kind of seen stabilize recently is sort of, quad-core architectures for the entry segment, the most cost-effective. So that still gives a very good performance for the entry point. When you get into kind of the mainstream and the high-end devices, octa-core architectures have tended to become quite popular. And then for MediaTek, at the super high end of our roadmap, we've introduced 10-core, deca-core architectures. But honestly, the point is less about the 10 cores, but it's more that we have architected it as what we call tri-cluster. So there's 3 clusters of cores, a high-performance core, a super low-end, low-power cluster of cores, and then a mid-range of cores as well. So the idea really is that you use the type of cores and the cluster of cores that best suit your application, not that you would have turning on all 10 cores at the same time. You're really more picking and choosing what the right configuration is for that particular task at that particular time. But does that always, and I always come back to this, is your multi-core processor only as smart as your operating system allows it to be? Yes, and at the end of the day, you're right. You have to have the control there to take advantage of it. So, what we've done, let's say take the deca-core architecture in our Helio X line of SoCs, where we have 3 clusters, big, middle, and low power. Of course, there's the hardware that manages all of the transitions from core to core, but even more important, I would say, is what we call Core Pilot. It's basically our scheduling and control software that sort of sits on top of that hardware. And it's basically, it's composed of a few different things where it's trying to look at the applications and look at the tasks that the user is trying to run and kind of analyze and sort of build up a profile of that so it can decide where to run things. It's also looking at the actual silicon, the thermal management, because there are physical thermal limits that you have to respect as well. So it may not, you may not be able to turn on a large core if the platform is already warm or hot. And, it's also kind of looking at the power usage and the scenarios that different applications might take. And it's basically making decisions with the operating system of, which tasks to schedule on which cores at which point in time.
Interesting. Okay, now let's look at this from a manufacturing perspective. Does it become extremely difficult to manufacture a processor with that many cores on it?
It's not necessarily from a manufacturing perspective, but of course, there is a certain amount of cost associated with adding more cores on the silicon always, right? So that's kind of why, at the entry space, I think quad core has probably become, fairly standard. Octa-core for kind of the segments above that, and maybe something even more above that. Of course, the progression of Moore's law from 65 nanometer to 40 to 28 to FinFET 16, 10 nanometer. That's obviously allowed for the integration or the putting down more physical cores on the silicon, cost effectively over the years. And if you look on top of that as well, the IP providers like ARM, for example, ARM's roadmap for cores has obviously been moving in two directions. There's sort of a performance vector where you just get more performance generation after generation, computing performance, that kind of thing. But there's also another line of processors that are really continue to be optimized for power consumption. So in some of the architectures like the Deca core, a good example right now is our Helio X30, which is our flagship product. That uses three different cores from ARM, right? So there's the highest performance one in the high-end cluster. We pick a mid-range Cortex-A53 for the mid cluster, and we use Cortex-A35s, which are more power efficient for the low core. So there's also a trade-off in terms of size, power, cost, and performance that you make for each of these clusters and each of these cores.
Okay, I love putting people on the spot, and you're under the spotlight right now. Pull out your crystal ball. It's 5 years from now. What are we talking about with respect to multi-core processing? Is it a fad? Is it gone? Are we looking at 300 cores? Are we looking at, I don't know, what are we looking at?
I don't think we're looking at huge explosion in the number of CPU cores going forward. I mean, I think like I said, we've sort of plateaued into kind of reasonable levels of quad core, octa core kind of architectures. I think what's more likely to happen as we go forward is if you look at kind of the use cases and some of the innovation that's coming, and I'm mostly speaking about mobile devices, smartphones, tablets, those kind of things. I think what we're seeing now is a lot more artificial intelligence, machine learning. We see it already with the voice assistants. There's an awful lot of innovation on camera and camera image processing, computer vision type stuff going forward. That's, I think, the wave that's going to shape some of these consumer devices over the next couple of years. And, I think the jury's still out, but it may be that it's not necessarily more CPU power that's needed, but it's different type of computing engines. So GPU processing, the use of DSPs or specific, more optimized cores for specific types of calculations. Maybe over time, even custom hardware for some of these kind of things. So I think it's much more likely we're going to continue the evolution of sort of what people have referred to as like heterogeneous multiprocessing, with different types of computing engines. You look at some of these high-end SoCs that we and other people in the industry produce today. They have multiple ARM CPUs. They have multi-core GPUs. They probably have some smaller control processors for some other things like sensor interfaces. They may have some DSPs for some specific functions around voice or imaging. Of course, they also have a whole bunch of other embedded cores in other places for things like the modem or the protocol stack. So they're already, multi-processing architectures. I think the question is more about, how do you use the available processing engines that you have, all different types, most effectively to, implement the kind of use cases and user scenarios that are coming, power efficiently, basically. And I'm not sure that that's necessarily more and more CPUs.
Very good. I really appreciate that look into the MediaTek roadmap. Very interesting. I'm afraid that we could talk about this for a long time, but we've used up our 5 minutes, so we have to stop here, and we will continue this discussion at a later time.
Perfect. Thanks for the time, Rich.
My pleasure. That was Finbarr Moynihan. He is the General Manager of MediaTek, and I am Rich Nass with Open Systems Media. Have a great day, Finbarr.
Thank you, Rich.